Hi everyone, my name is Alima and today we'll talk about the mass of a black hole. We'll talk about the introduction, the fundamental principles, the computational model, the results, and the discussion questions. In this experiment, we'll see how to determine the mass of a black hole from observing the motion of a star around it and use the fundamental principles used in this experiment were the momentum principle and Newton's second law, which stated that the change in momentum is proportional to the opposite of the net force times delta t. The net force in this motion has two components, parallel and perpendicular, which implied that the change in momentum also have the perpendicular and parallel components. The only force acting on the system is the gravitational force. As we can see in this illustration, both systems are attracted to each other. So here is the computational model where we enter the gravitational constant, the star mass, which is 2 × 10⁻30 kilograms, and delta t, that is 1 day converted into seconds. So for the loop, we calculate delta x and delta y for each x and y velocity values of the star motion. We then wrote the formula for delta p perpendicular and delta p parallel, which we included into F net, that is equal to the sum of both direction. And then from the gravitational formula, we solve for the mass of the black hole. So here is the motion of the star around the black hole through glow script. And we can clearly see the three forces acting. The perpendicular one, that is always through the center of the circle, the parallel one always parallel to the motion, and the net force. So analysis of the motion. As we can see, the net force is the orange arrow always pointing towards the black hole. The parallel net force is the magenta, which is always parallel to the motion of the star. And the cyan is the perpendicular net force, which also points inside the circle, so to the black hole. Here is a closer look at how we calculated the black hole's mass. Knowing that the only force acting on this system was the gravitational force, which is the net force, we set them equal and solved for the mass, which was 8.84 10⁻33 kilograms. What does it mean? How is the net force and its parallel and perpendicular components different from the rate of change of momentum and its components? So F net and the rate of change in momentum have the same direction, but are distinct from one another due to what they tell us about the system. For example, Fnet gave us the overall direction of the system, while the change of momentum tells us how the system is changing over time. So Fnet causes the momentum to change, so Fnet is the cause and dp dt the effect. What if the black hole whose mass we found was removed and a different black hole was placed in the same direction? Will we be able to tell the difference? Yes, we'll be able to tell the difference because the new black hole with the new mass will act differently on the star and therefore change the star motion and the force, the gravitational force. Therefore, with all those change, the new outcome, the new mass that we'll find will be different from the last one. Thank you. This is the end of the presentation.